I'm going to illustrate how to think about 4 different fraction comparisons using ways other than a procedure that might entail common denominator or changing fractions to a decimal. Certainly those are ways you can compare fractions, but I just want to illustrate ways that we can use conceptual reasoning and numerical sense making with fraction comparisons. So the first pair of fractions we're going to compare is 2/17 with 2/19. With 2/17, that fraction is saying I have 2 parts that are 17th big, and 2/19 I have 2 parts that are 19th big. And I know that 17ths are larger than 19ths, and that might seem counterintuitive because 19, the whole number, is larger than 17, the whole number, but if we have the same size whole and I split it into 17 things, and I have the same size whole and I split it into 19 things, those 17 things are going to be bigger. And so if I have the same number of pieces, so I've got 2 of those larger pieces, 2/17, and then I have 2/19, 2 smaller pieces, the 2 larger 17 pieces are going to be bigger. So 2/17 is bigger than 2/19. When I'm comparing 4/7 with 9/14, the first thing I notice is that 7 times 2 is 14, and so this is one of those tricky ones where it's like, okay, yeah, you could do this with getting a common denominator, but I'm going to press us to think about what that means conceptually. So if I have 7s and I have 14ths, and I split each 7th into 2 pieces, that means that if I split the 7th into 2 pieces, they're now 14ths. And so when I'm splitting my 7ths into 14ths, not only am I splitting all 7 pieces into 2 more pieces, which are now 14ths, but I'm looking at that part whole. So 4 of those 7th pieces are now also split up in 2. So if I took the 4 and split those into 2, now I would have 8 of them. And so I have 8/14. And so if I have 9/14 and 8/14, they're the same size pieces. And so since they are the same size pieces, I just need to compare the amount of pieces I have, and having 9 pieces of the same size pieces is more than having 8 of the same size pieces. So 9/14 is bigger. Ultimately, that is indeed what common denominator is about, but I just want us to think about what it means. All right, let's compare 3/7 with 6/11. This one is different from our previous one in the sense that I can't just split 7ths really nicely and get 11ths. Certainly, I could think about ways to split up things to get a common multiple or something like this, but instead, what I'm going to do is, the first thing I'm thinking about is, well, 3/7 does seem kind of close to a half. And the reason why I know that is because if I divide 7 by 2, I get 3.5. And so if I do that, I can think about what a half is with 7ths. So 3.5/7 is equivalent to 1/2. So that lets me know that this 3/7 is really close to a half, but it is slightly less than a half. And similarly, if I think about 6/11, and I think about comparing it to a half, because it does also look really close to a half, 11 divided by 2 is 5.5, so that means in 11ths, a half is 5.5 11ths. So I notice that 6/11 is larger than a half. So I have one fraction, 3/7, which is smaller than a half, and I have one fraction, 6/11, that is larger than a half. And so I can conclude then that 6/11 is the larger fraction. All right, now let's compare 8/9 and 12/13. What I'm noticing about this fraction comparison is that each of these fractions is one piece away from the whole. So for example, 8/9 is 1/9 away from the whole. So 8/9 plus 1/9 would get me to a whole, because 8/9 plus 1/9 is 9/9. And 12/13 is also one piece away from the whole, but it's a different piece. 12/13 is 1/13 away from a whole. And okay, so that's interesting that they're each, one piece away from their whole. So let's think about the size of those pieces. Well, 1/9, like that piece, a 9th, is larger than a 13th. And that's similar reasoning that we've talked about before, which is that although the number 13 is larger than 9 in whole numbers, when I'm thinking about 9s, what that means is I'm taking my whole and splitting it up into 9 pieces. And if I'm taking my whole and splitting it up into 13 pieces, splitting it up more times is going to make those pieces smaller. So the 1/9 piece is a bigger piece, and the 1/13 is a smaller piece. And so when I think about filling up a whole, whatever my whole is, if I'm doing it with 9ths and I'm filling it up, a larger piece is missing. Imagine that being this white space being the missing amount, and imagine this other rectangle being the same size whole. It's not, but a 13 is a smaller piece, so a smaller piece is missing. That's the white space. That's missing. So when a smaller piece is missing from the whole, that means more area can be covered. And because the smaller piece is missing and more area is covered, I can conclude then that 12/13 is the larger number.